This video is all about finding the standard form of a circle given its graph. The standard equation of a circle is quantity x minus h squared plus quantity y minus k squared is equal to r squared, where the coordinate hk is the center of the circle and r is its radius. Let's try finding the equation of a circle given the graph. What do you think is the equation of this circle? To find the equation of the circle, we just need its center and also its radius. So first, let us find the center. Based on the graph, the center is at point A, and point A's coordinate is 0, 0. Very good. The center is at 0, 0, or the origin. So we can say that our h is equal to 0 and our k is also equal to 0. Next is the radius. What is the distance of a point in the circle to the center? Based on the graph, the point on the circle is 2 units away from the center. Therefore, our radius is 2 units. Now we can have our equation, and our equation should be in this form. So, substituting h, k, and r, we will have this. X minus 0 squared plus y minus 0 squared is equal to 2 squared. In simplified form, it becomes x squared plus y squared is equal to 4. And that is our equation. Let's try another example. This is the given graph. So first find the center. The center is at point B. What is the coordinate of point B? The distance from the origin to the center is 3 units. That's right. And it doesn't go up or go down. Therefore, our center is 3, 0. So our h is equal to 3 and our k is equal to 0. Next is the radius. From a point on the circle to its center, we have 3 units. The distance from the center to any point on the circle is 3 units. Therefore, our radius is equal to 3. Now we can have our equation, which should be on this form. Now we can substitute h, k, and r to this equation. We will have quantity x minus 3 squared plus quantity y minus 0 squared is equal to 3 squared. And in simplified form, it becomes quantity x minus 3 squared plus y squared is equal to 9. Very easy. Now we can have our third example. What if we have this equation? The graph of the circle is located in the third quadrant. So we will have a positive value. We don't have a positive value. We just have both negative value. Our h should be negative and our k is also negative. Now, the center is located 5 units left of the y-axis and 3 units below the x-axis. So our center is at -5, -3. So our h is equal to -5 and our k is equal to 3. Now for the radius, as we have seen on the graph, any point on the circle is 2 1/2 units away from the center. Therefore, our radius is 2.5 or 5 over 2 units. Now we can have our equation, which should be on what form? Yes, this form. And then we can substitute. So, x minus negative 5 squared plus the quantity y minus negative 3 squared is equal to 5 over 2 squared. As you have observed, we have minus negative 5. When we subtract negative 5, it becomes positive. Yes, because we multiply negative times negative, it becomes positive. So we have x plus 5 squared plus the same with minus negative 3, it becomes positive. So we have y plus 3 squared is equal to 5 squared is equal to 25, and 2 squared is also equal to 4. That's why our r squared is 25 over 4, and that is our equation. Why don't you try it yourselves? Let's try finding the equation first of the circle x. What is the equation of circle x? Well, I know you can do it. Yes, that is right. Very easy. That is x squared plus quantity y minus 2 squared is equal to 16. Because its center is at 0, positive 2, and its radius is 4. How about circle y? Circle y's coordinate of the center is at the quadrant 3, so that should be all negative. What is its equation? That's quantity x plus 3 squared plus quantity y plus 2 squared is equal to 4, because its center is negative 3, negative 2, and its radius is equal to 2. And the last one, circle z. Circle z's center is at quadrant 4. Therefore, its coordinate should have a positive h and a negative k. Therefore, our equation of the circle is x minus 3 squared plus quantity y plus 3 squared is equal to 9. Did you get it? Well, that's good. Now you know how to find the standard form of the equation of the circle given its graph.